Hello everybody, hope you're having a lovely day so far. So today we're going to look at binomial expansion, and this is what I would call a very typical question on the binomial. What they generally do in these sort of questions is they will give you a binomial to expand, and then they will ask you to use your expansion for something. In this case, we're going to use it to approximate or estimate the value of 1.025 to the power of 8. So it's a really powerful tool, the binomial expansion. We can estimate things like this without having to resort to typical methods of calculator or computers. Now, there are two formulas for the binomial. Whichever one you choose is up to you. But I think in this case, because it sort of looks like 1 plus x to the n, we will use that one. Just a reminder, if you've forgotten what the formula is, it goes like this. So 1 plus x to the power of n is equal to 1 plus n times x plus, and then this is where the combinations start to come in. So n, lots of n minus 1 over 2 factorial multiplied by x squared plus n times n minus 1, n minus 2 over 3 factorial x cubed, and so on. Okay, so you can see the pattern here. We start off with 0 n's times by 1, then we have an n, then we have an n times n minus 1, then we have an n times n minus 1, n minus 2. If you look at the factorials, here we've got 0 factorial, 1 factorial, 2 factorial, 3 factorial, and so on. And then the powers of x are going up by 1 each time, because you can imagine there's like an x to the 0 here, this is x to the 1, x squared, and so on. Okay, so this is the formula we're going to use. Now, if you look at the formula we have, we've got 1 plus x over 4 to the 8. So what's actually changed between these two, between this one and this one, is that we've got n equals 8, and we've got x goes to x over 4. So I'm just going to write that in here. So n equals 8, and x is going to be replaced by x over 4. So let's work through. So using our theorem, or our formula, we've got 1 plus 8 lots of x over 4. And then we've got n minus 1, so that's 8 lots of 7 over 2, because 2 factorial is 2 times 1, which is 2. And then x squared, this is where a lot of students get tripped up. They forget to square, or they forget to just put the x over 4 in brackets. So they might forget to square the 4, for example, but you need to square the 4. And then we've got n minus 1, n minus 2, so that's 8 times 7 times 6 over 3 factorial, so 3 times 2 times 1, which is 6. Reminder, n factorial is n times n minus 1 times n minus 2 times 2 times 1. Okay, so it's a pattern where you multiply the number by the number before it all the way down to 1. Okay, and then we've got x over 4 cubed. Let's evaluate each term. So the 1 stays the same. 8 times a quarter x, well, that's going to be 2x. Then let's see what we've got here. So 8 times 7, 8 times 7 gives us 56, over 2 is going to be 28. And then we've got x squared over 16. And then we've got 8 times 7 times 6. Well, nicely, the 6's are going to cancel. So that's going to be 56 lots of x cubed, and 4 cubed is 64. And don't forget to add the dots, just to indicate that you understand that this expansion will keep going. Okay, just a little bit more simplifying we can do. So 1 plus 2x plus, well, 28 over 16 could go to 14 over 8, which could go to 7 over 4. X squared, and then 56 over 64, so that could go to 28 over 32, which could be 14 over 16, which could be 7 over 8. Okay, so there is our expansion all done. So we've got 1 plus 2x plus 7 over 4x squared plus 7 over 8x cubed. And again, this is just the first 4 terms, but it is good to show an awareness that this does keep going. Okay, so part B says, use this to find an approximation for 1.025 to the power of 8. So if we think about what we've got 1 plus x over 4 to the 8 is equal to 1 plus 2x plus 7 over 4 x squared plus 7 over 8 x cubed. How are we going to get these things to be the same? How are we going to get 1.025 to be equal to 1 plus x over 4? Well, we can just set up a simple linear equation for this. So let's change colour. So we've got 1.025 equals 1 plus x over 4. If we subtract 1 on both sides, what we get is 0.025 is equal to x over 4. And if we now multiply both sides by 4, what we get is, well, 0.1 is equal to x. Okay, just making sure I had my maths right there. So 0.025 times by 4 is equal to 1. 0.1. Yep. And this is quite a typical value for using in the binomial. Okay, it'll always be a small value of x, and 0.1 is quite often the one that's used. So all we need to do now is sub x is equal to 0.1 into our formula. Okay, so that's 1 plus 2 lots of 0.1 plus 7 over 4 lots of 0.1 squared plus 7 over 8 lots of 0.1 cubed. Okay, so we've got 1 plus 2 lots of... We've got 1 plus 0.2 plus, and then from here we can resort to the calculator. So we've got 7 over 4 lots of 0.1 squared, which is going to be 0.0175. And then we've got 7 over 8 multiplied by 0.1 cubed. So that's going to give us 7 over 8,000. Okay, and once we add everything together, we will get our final answer. So 1 plus 0.2 plus 0.0175 plus 7 over 8,000. So that is going to be 1.218375. And what did the question ask for? 4 decimal places. Again, this is quite common. So 1.218. The number after the 3 is a 7, so that's going to round up to 4. And that's the 4 decimal places. Now let's check that we've got a sensible answer here. So we're going to check, and we're going to plug 1.025 to the 8 into our calc, just to see if our answer is fairly close. Okay, remember it's an estimate. It's not going to be perfect, but it should be at least close. So 1.025 to the power of 8 is equal to 1.2184. Okay, so it is pretty accurate. Yeah, brilliant. So this gives us 1.2184. So again, we have done it correctly. Really hope you enjoyed. As I say, this is quite a typical binomial question, and for 7 marks of your A-level, it's pretty nice. Hope you enjoyed. Have a lovely day.